So if you have questions along the way, you need to make sure that you ask, because the stupid question is the question that was not asked. Just saying. So we're going to look at exponential and logistic functions today. There are 2 of your 12 basic functions. So we're going to also look at transformations associated with the exponential. So for exponential functions, they come in this form. Something times something raised to the x power. The a and the b are both numbers, so it has to be a number times some number raised to the x power, where a is not 0, because if a is 0, then you have y equals 0, which is the x-axis. And b has to be positive, and b cannot be 1. So b will not be the number 1. The other thing that you need to be able to find on these exponential functions, a lot of your homework questions want you to find out what is the initial value, and that's always whatever number is not raised to the exponent. So a, your initial value, is what's being multiplied to what I call the power. B, the x is your power. Whatever number is not raised to the x power, that's your a. And it can be disguised, and so we'll talk about that as we go along as well. And then b is called your base. B is whatever value is raised to that exponent. So let's start off and look at y equals 2 to the x. This is going to be a exponential growth graph. And for it to be an exponential growth graph, b needs to be greater than 1, or b is less than negative 1. Well, technically b is never negative. Mostly because, remember, it says b here is positive, but you're going to think it looks negative, and so I just want you to realize that we'll talk about the negative in a minute, but for right now, b has to be a number that's not a fraction. That's really what I'm trying to say. So if it's 1/4 or negative 1/4 or 1/3 or negative 1/3, that's not going to be a growth. That'll end up being your k. So let's go ahead and find an xy table. Whenever I do exponential functions, I'm always going to start off with letting x be 0. The easiest one to find. If I let x be 0, what is 2 to the 0? 2 to the 0 is 1. Anything to the 0 power is 1. So I'm not going to go right or left, but I'm going to go up 1, plus 1. Then if I let x be positive 1, what's 2 to the first? 2. So I have an x value of 1, but a y value of 2. And as x is getting bigger, you can see that y is getting bigger. So we'll do one more positive. When x is 2, what's 2 squared? 4. So when x is 2, y is 4. So let's choose some negative values. Ladies, pay attention. If I choose negative 1 for x, I've got a negative in the exponent. Remember what the negative in the exponent means to do. 2 to the negative 1. It's like a fraction. It does look like a fraction. Don't you take the reciprocal of the base? What's the reciprocal of 2? 1/2. And it's raised to the first power because it's negative 1. So the negative is the reciprocal. 2 becomes 1/2. And the 1, it's raised to the first power. So I get, when x is negative 1, y is 1/2. We'll do one more when x is negative 2. So the negative and the negative 2 flips it, so we still have the 1/2. But what's 1/2 squared? 1/4. So your y becomes 1/4. When x is negative 2, y is 1/4. And so it's just going to get closer and closer to the x-axis, but not actually touch it or cross it. Is there any value that x could be to make this function 0? Nope. Because I've chosen some zeros, some positives, and some negatives, and they haven't gotten us a 0 yet. And all that's going to happen is this is going to become a smaller and smaller fraction. So this is going to end up looking like this. And it's a growth model because as x approaches positive infinity, isn't y getting bigger and bigger and bigger? Y is growing and growing and growing. So growth is based upon our traveling from left to right on the x-axis. So let's look at decay. Decay occurs when b is less than 1 but greater than 0. So, already lost. No ruler. Pick a ruler. Save this so. Yep. I'll use this. Okay, so for decay, we're going to look at y equals 1/2 raised to the x. So 1/2 is the number between 0 and 1. Again, if it were negative 1/2, it would still be decay, but that negative is going to end up doing something else because technically b is not negative. So let's do an xy table. Again, I like to start with 0. What's 1/2 raised to 0 power? It is still 1. So both of these graphs have the same order of pair, 0, 1. Then if I let x be 1, 1/2 of the first power is still 1/2. So as I go to the right one, I'm going to go up 1/2. We'll do one more positive, we'll square it. So if I take 1/2 and square it, I have to square the 1 and square the 2. Don't I get 1/4? X is 2, y is 1/4, so it's getting closer and closer to that x-axis, but this time on the right-hand side. So let's do some negatives. If x were negative 1, 1/2 to the negative 1, what does that negative do to the 1/2? Nope, what does the negative do to the 1/2? It flips the base of 1/2. It doesn't make it positive, it doesn't make it negative. That negative 1 flips the base of 1/2 and makes it 2. So it's 2 raised to the first power. So 1/2 to negative 1 is actually 2. If you don't believe me, throw it in your calculator and check it. So when x is negative 1, y is positive 2. Do one more, negative 2. So if x is negative 2, that negative still changes the 1/2. It's reciprocal, which is 2, but now it's squaring it. So what's 2 squared? 4. And x is negative 2, y is 4. So you have just the reverse going on. It actually looks like the graph has been reflected across the y-axis, doesn't it? So that reciprocal kind of has the same effect as having a negative in there somewhere. Because we know that negatives reflect things either over the x or the y-axis. It just depends upon its placement. And you'll see the importance of a negative to that base in one of our problems in a minute. So let's look at our domain for both of these. Both of these have the same domain. Is my x restricted on my domains? Can I choose any values I want to for x? Yeah, I did. I chose positive, negative, 0, so it's unrestricted. So both have domains of negative infinity to positive infinity. What about the range? Is the range restricted? Are there any negative range values? No. So the range starts at what number? See, isn't this horizontal asymptote right here? Because it's approaching on the right, y equals 0, which is the x-axis, and on the left it's approaching y equals 0. So both of these graphs have a horizontal asymptote of y equals 0. Both of them do. Which means that it restricts, any horizontal asymptotes tend to restrict the range. So my lowest range value would be 0, but not including 0, because as we discussed, we can't make that value 0 by choosing anything for x. Nothing's going to make this 0. And it'll go to positive if it's 1/2. Are the graphs bounded at all? Above, below, or just bounded? It has a bottom to it, right? Anytime you have a horizontal asymptote, it's going to be bounded. So because the horizontal asymptote is at the bottom of the graph, it is bounded below. So these are bounded below both of them. Both graphs are considered continuous for every value of x. There are no holes in the graph, there's no vertical asymptote, so it's continuous at all values for x. All right, so let's look at some examples of what are exponential functions and what do they look like. We're going to start with this one, a. F of x is equal to 5 raised to the x power. You have a numbered base raised to a variable exponent. True or false? True. So this is yes. If it's yes, you're going to be asked to identify the initial value and the base. I like to identify the base first. You can identify what's being raised to the x exponent, then what's not being raised to it will be your initial value. So isn't the 5 being raised to the x? So that's my base. So what would my initial value be? It would be 1. Isn't there? If you can't see it, what's being multiplied to this power? It must be 1. So it has an initial value of positive 1. Because if I were to put a in there, it's a times b to the x. Well, b is 5. When we don't see something, it'd be no different than just having a variable of c there. If you have a variable c, what's the coefficient? 1. So we're really asking for what's the coefficient in front of that power, if you want to view it that way. So the power is 5 to the x. So if I cover that up, there's nothing there. What do you see or what do you think is there? It has to be a 1. Same thing occurs. Don't write this down because I don't want your notes to get confused. But if I put a negative right here, no parentheses, just a negative right there, is that negative being raised to the x power? It's not, because it's not in parentheses. And so this is the other way that you could see this occurring. Do not tell me that the base is 5. The base cannot be negative. The base is never negative. Nor will they put parentheses around that, because then it's been changed. It's no longer an exponential function. So that base has to remain positive. So in this case, my base would be positive 5, but the coefficient, if you will, in front of the power being 5 to the x, is really negative 1 times 5 to the x, but you would never write it as negative 1 times 5 to the x. So your initial value here would end up being negative 1. Does that make sense? When you have a negative. And that negative is affecting the whole value of the function, isn't it? If I had that negative there. So if a negative affects the whole value of the function, it's a reflection always with a negative. Would it reflect over the x-axis or the y-axis? It's affecting the whole function. Is the whole function x or y? The whole function.
Why?
Because the whole function is f of x, right? And it is an f of x y. So if you have a negative that's on the outside affecting the whole function, it's going to reflect over the x-axis. Because whatever I take 5 to and raise it to, won't I multiply it by a negative 1? Won't all the y values be negative? They'll end up reflecting down over that x-axis.
So is the initial value the exponent, or is it the other number that you can't read?
The initial value is the number you can't see in this place. It's the exponent is neither the initial value or the base. It's whatever's in front. Like, I could have easily written this as 2 times 5 to the x. And I'd have to write it this way, because otherwise if we smushed it together, it would look like 25 to the x power. So they'd have to write it this way or this way. So any questions on how you find that initial value? The initial value is a harder one to find. Just note to self on your notes here, that base must always be positive. I'd write myself a big note about that, because that's an easy one to forget. So note to self, must always be positive. Always. So then look at the second one, b. 5x to the third, is that an exponential function? Yes or no? No, why? Alright, so the correct answer is no. It does not have a numbered base. B is not a number, it's a variable. So that number 1 is wrong. And then number 2, the exponent has to be a variable. And it's not. So it's got 2 wings against it. Isn't this really an S curve? Right? So it's not an exponential graph. Look at C. This one's much easier to see the initial value, isn't it? You have a numbered base, 3.2, being raised to a variable exponent. So this, yes, is an exponential function. So what's the base? The thing that's being raised to the x power is 3.2. So that base can be a decimal. And since it's a decimal greater than 1, it's exponential growth. What's the initial value? That can be negative. So that one is negative 4. Now D is a little bit more difficult. Is it an exponential function? Do you have a numbered base? Yes. Is it raised to variable exponent? Yes. So pass both pass. Therefore the answer is yes. What do we have there? It can be growth or decay. Right? So isn't this one going to be decay? Does that make sense? So yes, it's still exponential, but it is decay. And notice that decay really is a reflection across the y-axis. And we're going to rewrite this in a different way. Or, tell me if I could rewrite it this way. Could I take the reciprocal of my base, so I have 3 times, instead of 1/2, I'm going to take its reciprocal, 2. If I take the reciprocal of the base, what do I have to do to the exponent? Change its sign, so doesn't it become a negative x? Now I'm only showing this to you because I want you to understand why the decay is actually a reflection across the y-axis. So you have this negative. Isn't it affecting the x value? When it affects the x value, it's inside that function, it's affecting the x value. It gets reflected over the other axis, the y-axis. So that's why we end up with something that looks like this, reflecting the opposite direction. Now, don't answer the following questions using this. If they give you this as the original problem, your initial value versus your base, you should be using this to answer your base questions, because otherwise, if you use this, wouldn't you be saying the base is 2 and your initial value is 3? Well, Math Excel is probably going to count that thing wrong. So if I saw you write it this way on my test, I probably would accept a base of 2. But Math Excel is not going to accept that. So isn't your base 1/2? That tells you right there that it's decay. Because the right-hand side is what is approaching 0. And then what's your initial value? It's 3. It's the number that's in front of the power. So any questions on finding initial value of base? Yes. I would be using the original always. But I wanted you to see that that's why it's a reflection. That I can actually really take decay and write it so it looks like it's growth. But if you have a negative exponent, it ends up being reflected and becomes a decay product. We're going to go through transformations here in a minute. Yep. Let me give you one additional question in this section so you can title it E. What if you had y equals 5 times 6 raised to the pi? Is that exponential, yes or no? No? Why no? What kind of a number is pi? It's irrational. It's actually a real number, isn't it? It's not a variable. It looks like a variable, but it's actually a real number. So it's no. It's a function still, but it's just not an exponential function. There's no variable in this. Would you agree? This is actually going to be the equation of a straight line. Because 6 to the pi is an actual number, times 5 is an actual number. So you have y equals an actual number, which is a horizontal line. So it's definitely not exponential. It's constant. All right, so then transforming. We're going to use our past knowledge and our calculator. And we're going to guess what's going to happen to the graph of 5 of the x. So we have this graph, 5 of the x. That's our original graph. And we're going to do things to it. So the only difference here on A is what happened in the exponent. So go back to what you've been taught. The -1 is affecting the x or the overall function? It's affecting the x. So it affects the x, isn't that a right-left motion? True or false? Right-left. Same sign or opposite sign? opposite sign. So what do you anticipate is going to happen with this graph? So it's going to be a horizontal shift because it's right left. Because it's -1, we're going to go in the opposite direction, right 1. So I anticipate that the graph of 5 to the x is going to move to the right 1. So if this were the graph of 5 to the x right here, I would take each one of these ordered pairs and just move them to the right 1. It's just a curvy graph. So let's go ahead and put that in our calculator. So I'm going to move out. Yeah. Because it's happening inside the function. Anything inside the function is opposite sign, and it's happening to the x. When it's happening to the x is normally the right-left direction. So because we're doing opposite of -1, that means we're going to go to the right 1. And so let's see what happens. Okay, so I'm going to put 5 to the x in. And so that looks like this. That's our normal 5 to the x. So it's a little closer to the y-axis than my one up here of y to the 2x, which kind of makes sense. We have a vertical stretch kind of going on here with that base changing. But let's see what happens with that exponent. I'm going to put the second graph right below so we can see the change of plane. So there's the first, there's the second. Didn't it get shifted to the right? It's the same shape, just got shifted to the right. So our guess was true. Look at the second one. The only difference here is we have a negative in that exponent. So the negative is happening to the x. We're inside the function, it's affecting the x. So where does it get reflected? Over the other one, the y. So this should be a reflection over the y-axis. If the negative were on the outside with a 5, that would be affecting the whole function, so that would be affecting y, which means it would be reflected over the x-axis. So a negative on the outside is over the x, a negative on the inside of the exponent is reflected over the y. So let's see if that truly did occur. Let's change this one. So there's the first one. The second one should be flipped. There it goes. If in doubt, check in your calculator. There will be a calculator portion to your test and a non-calculator portion to your test. So if I'm telling you not to use your calculator on certain things, you need to not use your calculator. So I would expect that this will be on the non-calculator portion of the test. You have to know how to do the translations without your calculator, which you can use it to check for right now. Yes.
Are we going to have a quiz or just
You will have a quiz. And then you'll have an overall test. The calendar's up right now for chapter 3, so you can look at that. Then here, our only difference to the original function is this. A positive 2 being multiplied on the outside of the function. When you're multiplying by a number greater than 1 on the outside of the function, is that affecting the overall function, or is it affecting the x? Is it inside the function or outside the function? Okay. It's outside, right? If we're affecting the x, the 2 would be 5 to the 2x. So it's affecting the x, it's usually touching the x. If it's not affecting the x, it's on the outside. So because it's on the outside, does not affect the y, the whole function, and affects the y is an up-down kind of thing, but this is not a translation. I don't see plus or minuses here, right? It's a stretch. Why is it a stretch? Because I'm multiplying, and it's a number bigger than 1. And it's outside the function, meaning it's affecting y. Doesn't y go vertically? So that's how I remember, okay, it's a vertical, and it's a stretch. Of 2. So let's see if that happens. If it's a vertical stretch, should it get closer or further away from the y-axis? Closer or further away? Closer. So let's take this one away. I'm going to do 2 times, whoops, not x, 5 to x. So there's the first one. The second one should be inside. And there it goes. So just slight stretch. Pulling it this way. Just pulling it closer. And then the last one on here. This one's interesting. It actually has two transformations occurring. Is the x where we normally like to see it? Don't we like the x to come what? First. So the first thing I'm going to do is change the x's first. So it's really a negative x plus a 2. Then do we like the x to be negative? We're going to factor out a negative 1. So I'm going to factor a negative out in front of parentheses. And I end up with a positive x but a minus 2. Now you can see the transformations that are going on. This negative right here, what does that mean? It's a negative in the exponent. Is it affecting the x or the overall function of y? It's affecting the x because it's inside touching the x. Isn't it touching that x? It's inside touching the x, so it's affecting that x. It's going to hit you one day. You're going to go, I got it. And then, so it's affecting the x. A negative is always a reflection. So where are we reflecting? Over the opposite one. So it's a reflection over the y-axis because it's affecting the x. It's touching that x. Write your notes. And then this part right here, is it affecting the x or the y? It's affecting the x. So, and it's a plus minus kind of thing, right? So isn't that right-left movement? Is it same sign or opposite sign? Opposite sign. So that means we are doing a horizontal because y is, or the x-axis is horizontal. Shift. Am I going right or left? Right. 2. So I anticipate that my graph is going to be shifted right 2 and reflected over the y-axis. It's probably easier if you reflected it over the y-axis first and then shifted it right 2. Because otherwise, if you shift it right 2 and then try to reflect it, your axis of symmetry, which is the y-axis, has shifted also. So if I were you, I would be doing my reflection first and then my shift second. So let's get rid of this and put in 5 to the 2 minus x. So there's the first, that's original. And then the other one should be going the opposite direction but moved over to the right, which it does indeed appear to have done. So questions on that? Okay. You will learn one new thing on here. We'll get to it shortly. Now let's look to see what happens when the base changes to e. This is still an exponential function, but now the base is e. E is a number just like pi. It's irrational. We use it all the time with logs. And so let's look to see what is y equals e of the x. I'm going to put that on my calculator. Do you know where your e is? Where is it? It's above the division or below the caret button. But if I do second division, I get my e, and then raise that 3x. Is that an exponential graph? Yes. Yep. So guess what happens when x is 0? What's y? What's e to 0? Still 1. So this graph also has 0, 1 as a common factor, but it goes just like the growth model. It goes to the right. So as, what is the limit as x approaches positive infinity? And we're going to call this f of x. What happens to the limit as x approaches positive infinity? What's happened to y? It's going up, isn't it? So what is that? Positive infinity. What is the limit as x approaches negative infinity of the function? As I go to the left, what's y actually approaching? Isn't y getting smaller and smaller and smaller and smaller? It is getting smaller, but what number is it actually approaching? 0, because it's not actually ever becoming negative, right? So it's not negative infinity. It's approaching 0. Anytime you have and that means it also has a horizontal asymptote of y equals 0. So anytime it approaches a horizontal asymptote, that becomes a limit. So you might want to study that. What's the domain? Can I put any value I want to in for x? Positive, negative, 0? Yes or no? Yeah. So the domain is unrestricted. What about the range? Bless you. Where does the range start? At 0, that horizontal asymptote. Does it include 0? Nope. And doesn't it go to the positive infinity? And this is also continuous for all values of x. Is it bounded? Yes. It is bounded below. So it is bounded below because it has that horizontal asymptote. So it's all prior knowledge, yes? We're still employing all of it. Okay. Now what are we going to do with this? We're going to do some transformations. So let's look down here. This one's interesting. What do you think will happen with this one? A 2 in the exponent is affecting the x or y. It's affecting the x. So if it's affecting the x, is it vertical or horizontal? It's horizontal. In the past, what have you known it to be? If it's 2 and not a fraction. Stretch or a shrink? It'd be a stretch, right? Well, let's look to see what happens. So I'm going to put here e to the 2x. So the first one is the original. There's the original. What happens to the second? It went inside. If it's horizontal and it went inside, then that means that I must have pushed it horizontally to get it to go up towards the y-axis. I did not stretch it horizontally. So if I stretched it horizontally, then this would have been lower than the original. So if I pushed it horizontally, is that a stretch or shrink? It's actually a shrink. So this one's different than what our past has told us. So this is actually, and you might want to star this and circle it. This is actually a horizontal shrink of 2. So doesn't that mean that if the 2 becomes a 1/2, what's going to happen? If I change the 2 to a 1/2, what's going to happen? Instead of shrinking, what's going to happen? It's going to stretch it, and shouldn't this tail here be lower up here? And so let's see if that truly does occur. Yeah.
So when the exponent is directly down,
Because it's affecting the x. So because it affects the x is horizontal. So that's why I know it's a horizontal. In the past, if it's been 2, that was a horizontal stretch, which brought it closer to the x-axis, and a 1/2 would have made it a shrink closer to the y-axis. But because it's in the exponent, the behavior changes. We haven't had the x in the exponent before, and so that's why this is the one transformation which it changes behavior. And so look what happens if we change that to a 1/2 here. So I've got e raised, and I want to use exponents, 1 divided by 2x. So my original is the first, and then my second should go closer to the x-axis, and there it goes. So note to self, when it's a number greater than 1, then it's going to be a shrink. Less than 1, it's going to be a stretch horizontally. So that one is different. Star it, study it. The rest are all the same. So what do you think the e to the negative x is going to do? It is affecting the x, and negative is always a reflection. Because it's affecting the x, it's reflected over the y-axis. Outside the function of 3, this part did not change. What is that? Affecting the outside. It's multiplication on the outside. It's affecting the y, the whole function. So y is vertical. Because it's greater than 1, it is a vertical stretch of 3. A negative on the outside of the function. A negative always means a what? A reflection. But it's affecting the outside of the whole graph because the negatives are occurring on the outside, it's not touching the x. So if it's affecting the outside, the whole outside is y, so where does it get reflected? Over the x-axis. So I talk to myself a lot. You should be doing the same thing. Raising yourself through these problems. Although I'm not a crazy lady with the cats, so yes. My husband would divorce me if I had even one cat. All right, so then let's move to logistic functions. So I'm going to put this in my calculator. Remember the logistic function is that F-shaped function? And so let's see what that looks like. You gotta use parentheses. 1 divided by all of this. 1 plus e raised to the negative x. And then end those parentheses. So when you originally look at the graph, it doesn't look like much. What have we learned that we have to do with graphs that look like this? Zoom. Am I going to zoom in or out? I'm going to zoom in. I want to see what's happening. I'm going to focus in closer. So I'm going to hit my trace button to make sure that I'm zooming where I want to, and that's kind of where I want to zoom is right there. So now I can do zoom in and hit enter. It's still kind of hard to tell, but this is actually hitting at 1/2 right here. And we'll find the y-intercept here in a minute. But this number right here is 1. It's approaching on the right-hand side, y equals 1. Logistic functions always have 2 horizontal asymptotes. The original logistic function is y equals 1, and then on the left, where it's approaching, y equals what? 0, and it doesn't cross it. So in the original, yes, exactly. Well, hang on. Are you down below?
No.
Oh, up here? Right here? No. It can happen if my base, so if I had 5 to the 2x, you should see the same thing happening because they're both exponential functions. But a good question. All right, so then here, your normal, you need to learn this. Your normal horizontal asymptotes for a logistic function would be y equals 1 and y equals 0. The 1 comes from here. Whatever that numerator is, that's your horizontal asymptote at the top. And they will always approach y equals 0. There will always be one of the other 2 asymptotes. And then, is my x restricted, my domain? Yes or no? Domain restricted? Nope. So my domain is negative infinity to positive infinity. I can choose any values I want to for x. And then what is my range? If I've got 2 horizontal asymptotes, y equals 1 and y equals 0, what are my y values going to be between? 0 and 1, right? So my range goes from 0 to 1, but does not include that. So the logistics actually has a double restriction on that range. Every time you have a horizontal asymptote, it affects it. So then look at your limits. My limit, and let's go ahead and plot this. I'm going to stretch my graph out a little bit so we can see what's going on. I'm going to have every hash mark with a half. And so there's my 1 and negative 1. I know my y-intercept. How can I find a y-intercept really easily? What's the value of x on the y-axis? What is it? Everybody needs to think for themselves. What's the value of x on the y-axis? 0, isn't it? On the y-axis, isn't the x value 0? So I'm going to go to my table features. Second table. What is x? 0, what's y? 0.5, which is 1/2. So here, my y-intercept is 0, 1/2, and I found that by using my table feature. So I'm going to plot an ordered pair at 0, 1/2. And then I have my horizontal asymptotes. I have one here. This is y equals 1, and then one here of y equals 0. And then on the right, it's going to approach here, and on the left, it's going to approach down here. So that's what my graph looks like, this little S curve, but sideways. So let's look at limits. I'm the vertical asymptote, so my limits are going to be positive, negative, infinity. So the limit as x approaches positive infinity of f of x, because I don't want to write that right now. So as I approach positive infinity, what's happening to y? What's it approaching? On the right, what's it approaching? 1. Very good. One of those horizontal asymptotes. The limit as x approaches negative infinity of f of x. Some of you don't know your function notation, by the way. So as I go to the left, it is approaching 0. Very good. So those horizontal asymptotes are going to affect the limits as well. So let's look at two problems. Let you finish writing that. So let's look at A. You're going to need your calculator to help you with this, although for the most part you're going to be able to do it without your calculator. The hard part to find out would be your y-intercepts, although you can still do it. So I'll kind of talk you through it with a calculator without a calculator. So we're going to put this into our calculator, the y equals. So I'm going to get rid of that original. I'm going to do 8 divided by, you must use parentheses. So 1 plus 3 and use multiplication symbol. 0.7, so I have a 0.77 e this time. It's okay. Still will be logistical. Raised to the x. And end those parentheses. What we propose is going to happen to our horizontal asymptotes. What did I say about where these came from before? So there's a 1 up here, so one of them became y equals 1. So there's an 8 here, so what do you think one of them is going to become? Y equals 8. Let's see if that happens. So graph. Oh, what's wrong with my graph right now? It's zoomed in, so I'm going to zoom standard. So here's the standard zoom, so it kind of looks like that S function, right? Andy. Okay, so here's what I'm going to do first. I'm going to find my y-intercept first. How do I find the y-intercept? Use my table function. So I'm going to do second table. And then 0, 2, right? So the very first thing I'm going to do is find my y-intercept. And you can write yourself a note that you use the table feature, but we did write it above here. So I'm going to plot that point, but I know that I'm going to have a horizontal asymptote right here, horizontal asymptote of y equals 8. And we're going to look on our graph in a minute to see if that's what happened. I'm going to have another one of y equals 0. Well, I don't have 8 hash marks here, so what should I be doing? I'm going to adjust my scale. What should I go by? 2 sound reasonable. So that would be 2, this would be 4. 6, 8. So I'm going to put a horizontal asymptote there. And label it y equals 8. And label this one y equals 0. Because we have 2 of them. I know where my y-intercept is it's at 0, 2. So I've got that one right there. I'm plotting that. From here on, I'd just be able to go up and approach this, and down and approach that. All I need is my y-intercept and my two asymptotes, and I can draw my function. Now, how can I get that asymptote without my calculator? What do I let x equal for y-intercept? Or I'm sorry, how could I find my y-intercept? What do I let x equal? 0. So does that whole base become 1? 0.7 is 1. What's 1 times 3? 3 plus 1, 4. What's 8 divided by 4? 2. Couldn't you have found that without your calculator? And we know because of the 8 here, one of our asymptotes is here, and the other asymptote is 0. So you can do it without your calculator. So think about it without your calculator. Then let's look at the graph and double check. If I zoom out, you can see the top part of the S because what's this part doing? It's approaching what? 0. So the left limit is 0. What's the right limit? No, 8, because it's approaching that horizontal asymptote. If I zoom in, I'm back to my standard, and you can kind of see that up here is that asymptote, and that's what it's approaching. It's starting to approach that asymptote of 8. And you can move it along, and you'll see that it never goes past 8. And look at your y. And so now it's going to start to get really close to 8, but not go past it. You're like, surely it's going to go past it at some point. But now what's happening? It's never going to hit it, right? So, zoom standard. All right, so let's do the last one. So for this one, what do you propose? What's our asymptotes? 20. There you go. So y equals 20 and y equals 0. So I'm going to have to adjust my scale here. I'm going to go by 4s. So this is 4, then this is 8, then add another 4, this is 12, another 4, 16, another 4, 20. So 20 is up here. So I'm going to put that as one of my asymptotes. So y equals 20 and y equals 0. So my y-intercepts, I can also do without my calculator. If I let x equals 0, oh, well this one's a little harder, isn't it? No, it's not. If I let x equals 0, isn't the e the only thing being raised to 0? So e to the 0 becomes 1. Times 2 is 2, plus 1 is 3. Isn't it 0 and 20/3? Which is about 6 2/3. So plot a point at 6 2/3, which is right about here. And then approach your asymptotes. That was exciting. And so it still should look like that S curve. So you can do it without your calculator, quite easily. Whatever that base is, you're going to raise it to a 0 power and it becomes 1. Any issues, problems, or concerns? So what's my limit as x approaches positive infinity on this side? 20. And my limit as x approaches negative infinity? 0. 20. What? The y-intercept, I just let x equal 0. And that means that whole exponent is 0. And only the e is being raised to the negative 3x anyway. So the e to the negative 3x becomes 1 times that 2 is how I got the 2. Because the 2 remembers that value that's not being raised to the exponent. It's not in parentheses. Any other issues? Okay.